This video is to go over the answers to any Keystone questions from the current assignment. So looking at number 1, it's asking which of the following inequalities is true for all real values of x. So when we get a question like this, we really want to focus on 3 different types of numbers: negative numbers, positive numbers, and 0. So, for example, in this case, it would not be choice A because while positive numbers will always be greater than or equal to x squared, while positive numbers that are cubed will always be greater than or equal to positive numbers that are squared, negative numbers would not be. Take, for example, negative 2 to the third power. Make sure to put that in parentheses. Stating that that's greater than negative 2 to the second power. Well, if we simplified this, then we would get negative 8 is greater than or equal to positive 4. Well, that's definitely not true. So in this case, A would not be an answer. B would only be true for negative numbers along with 0. It is not true for all positive numbers. And then C, if we tested a negative number, a positive number, and 0, this would be true. Notice C would simplify to 4x squared is greater than or equal to 3x squared. All right, and x squared will always be the same quantity, and it will always be a positive quantity or 0. And therefore, since 4 is always greater than 3, C would be the answer. Number 2, an expression is shown to the right. Which value of x makes the expression equivalent to 10 times the square root of 51? So one thing we have to notice is originally our term outside of the square root is 2, and it changes to 10. So right from there, we know that 2 times 5 equals 10. So we have to think 5 equals the square root of what number? Since we know from the product property of radicals that the square root of 51x is the same as the square root of 51 times the square root of x. Therefore, this 5 is representative of the square root of x, while the square root of 25 equals 5, and therefore that is your answer. In number 3, we are looking at the least common multiple of these monomials. So as I've said before, a least common multiple, or just a multiple, has to be greater than or equal to either term. So either term. And this one actually is pretty simple, since if we look at the coefficients, 2 is not greater than or equal to 450 and 3,000. 30 is not greater than or equal to, and 150 is not greater than or equal to. Just from recognizing that, it means the answer has to be D. Looking at number 4, this is a simple case of you can just use your calculator to simplify. You will get a decimal, but once you get that decimal, if you click the button, I believe you have to click second first, but if you click F to D, it will change a fraction to a decimal or vice versa. And in that case, you would get 1/8. Now, if you want to break this down, we could simplify. So first, 2 times the square root of 4. Well, the square root of 4 is 2. So 2 times 2 is 4. And then 4 to the negative second power. Now, remember, 4 to the positive second would be 16. So 4 to the negative second would be 1 divided by 16. Or we could have simply said, 2 divided by 16. And then if we simplify that, we get the fraction of 1/8. Looking over at number 5. A theme park charges $52 a day for a day pass and $110 for a week pass. We're told how many day passes were sold and how many week passes were sold. Well, to find the closest estimate, we would take the number of day passes sold times the number, or the cost for a day pass, and that would equal about 230,000. Notice I said about since we're estimating here. And then we can also calculate the amount sold in week passes, so 979 times 110, and that would be about 108,000. So if we add those two quantities together, we get 338,000. So estimating, notice this amount is closer to 300,000 than 400,000, hence A would be our answer. In number 6, we are multiplying these polynomials. As a reminder, we can use the generic rectangle. Since the first polynomial is 2 terms, we put that on the side with 2 rows. And then the second polynomial is 3 terms, so that must go up above where there are 3 spaces. And then we are simply multiplying each term through. And then we can combine like terms. So our x squareds add to 11x squared, and then our x's add to 17x. Hence, A would be our answer. In number 7, we are factoring this trinomial. So remember, that means we're starting with the area, and we have to find the side lengths of the rectangle. As we've talked about before, the first and the last term have to be diagonal since they do not share a factor of x. We also know that the remaining 2 boxes would have to add to negative 3x. So we're just trying to break apart that quantity so that the total inside of the rectangle equates to what we started with. So we know we have to add to negative 3, but we also have to multiply to 1 times negative 18. So multiply to negative 18. So those 2 numbers would be negative 6, and I have to make this x, and then positive 3x. So notice we are breaking down negative 3x into these 2 terms, which do add to negative 3x. Then if we factor, so looking at our common factors among each row and each column, this is x and x. And then this is plus 3 and minus 6. In question number 8, this is a lot of factoring. Notice I started it for you. I actually took out what's called the GCF of each polynomial. So the GCF of the numerator is negative 3x, and is also the GCF of the denominator. Now, since we have negative 3x divided by negative 3x, that divides out. So we're left with these 2 polynomials. Now, to make this work, we will have to factor each one and then determine if we have any common factors that will divide out. So looking at factoring this first one, we have to add to negative 3x and multiply to negative 10. So that would be negative 5x and positive 2x, making our factors x plus 2 and x minus 5. And then in the bottom generic rectangle, we have to add to 6x, but multiply to 8. So that would be 4x and 2x. So then once again, we factor each row in each column. That's x plus 2 and x plus 4. Now we can rewrite the numerator and the denominator as factors. And this is what that would look like. Now notice we have a common factor of x plus 2, so these factors divide out, and we are left with x minus 4 divided by x plus 4, hence D being the answer here. In question number 9, Jenny has a job that pays her $8 per hour plus tips. She worked for 4 hours on Monday and made $65 in all. So to find how much she made in tips, we know that 65 is the total amount, and if she made $8 per hour for 4 hours, we have to multiply them, and then we would simply add on the number of tips, making D the correct answer. In number 10, one of the steps Jamie used to solve an equation is shown below. Notice we started with this equation, and then she applied something to end up with this. Hopefully you recognize that she distributed the -5 to get -15x and -35. Therefore, we would say she multiplied 3x and 7 by -5, and this is justified by the distributive property. In number 11, we are told that Francisco purchased X hot dogs and Y hamburgers at a baseball game, and he spent a total of $10. The equation below describes the relationship between the number of hot dogs and the number of hamburgers purchased. The ordered pair 2, 1 is the solution to the equation. Now this boils down to what do X and Y represent? So 2 represents the number of hot dogs. And 1 would represent the number of hamburgers. And that simply matches up with option B. Number 12, Anna burned 15 calories per minute running for X minutes, so that is unknown, and 10 calories per minute hiking for Y minutes, so that is unknown. She spent a total of 60 minutes both running and hiking and burned 700 calories. So we can use a system of equations to figure out exactly how much time did she spend running versus hiking. So think about this equation represents how many calories she burned, and then this equation represents the total number of minutes she exercised. Now, we can use one of our strategies to solve this system. However, if you think about the fact that the answer is given to you, you can check which one works. So for example, if X represents the amount she spent running, but she exercised for a total of 60 minutes, then if she ran for 20, that means she hiked for 40. If she ran for 10, that means she hiked for 50. If she ran for 30, that means she hiked for 30. And if she ran for 40, that means she hiked for 20. So which combination of these XY pairs would also make this equation true? So if we tested each one, then the only one that would work is option B. And we would take 15 times 20 plus 10 times 40, and that would add up to a total of 700. So notice I did not use any strategy of solving systems of equations. I simply used the fact that the answer was provided for me and checked to see which one worked. Question number 13, we're told Samantha purchased 5 roses for X dollars each and 4 daisies for Y dollars each and spent $32 total. We're also told about Maria's purchase. So this first equation represents Samantha and the second equation represents Maria. Now, unfortunately, this one you do have to solve for X and Y to really recognize what the correct answer is here. I would suggest using elimination to do that. Say I want to eliminate the X variable, so I multiply the second equation by -5, and then I will rewrite both equations over here to show how we can combine them. So the first equation stayed the same. The second equation, I just distributed the -5. Sorry, I made an error at first. Then we can actually add up the equations. Oops. Notice 5x plus -5x equals 0. 4y plus -30y is -26y. And then 32 plus -110 is -78. So if I divide both sides by -26, it tells me that y, aka the cost of a daisy, equals 3. And then we can plug that back in to one of the equations. I'm going to plug it into the original second equation. So x plus 6 times 3 equals 22. 6 times 3 is 18, meaning that x equals 4, which is the cost of a rose. And if a rose costs $4, a daisy costs $3, then A would be the correct answer, that a rose cost $1 more than a daisy. In question number 14, a compound inequality is shown to the right. So we have to solve for y here. As we've said before, we treat this just like a regular equation. However, if we apply something, we must apply it to all 3 quantities. So we start by subtracting 2 from each quantity. So then we have 3 is less than -3y is less than 12. Then I would divide everything by -3. And as we've said before with inequalities, if we divide by a negative, everything becomes the opposite. So this +3 becomes a negative, and then dividing by the 3 is -1. This symbol switches, and then we just have y. This symbol switches, and 12 divided by -3 is -4. So notice if we write this now from least to greatest instead of greatest to least, we'd have -4 is less than y is less than -1, and that matches up to B. If you're unsure of how to solve this or answer this by solving for y, you can test potential values within these ranges. Now, the only thing is you have to make sure these are true. So for example, C doesn't work because it's not possible for y to be less than 1, but also greater than 4. Same thing would apply to A. Y cannot be greater than -1, but also less than -4. So it's actually between B and D in the first place. For number 15, notice that all of the expressions are the same and all of the original quantities are the same. The only difference are the symbols. So we know that somewhere in here we're going to have x and -3. We just have to determine what symbol would be represented by this open circle and the arrow to the left. So right away we know with the open circle we should eliminate these symbols that include equal to. And since our solutions are less than -3, we would choose this symbol. And notice that matches up to the symbol in A. For number 16, you were simply solving the inequality given to you. So you started with 185 plus 4b, and that must be less than or equal to 1,000. So we're solving for the value of b. So if we subtract 185 from both sides, then we get 4b is less than or equal to 815. Dividing both sides by 4, we get b, or the number of baseball bats, is less than or equal to 203.75. So the number of baseball bats must be less than or equal to this quantity. Now, since we can't buy a portion of a baseball bat, we would actually round down and say the number of baseball bats we can buy is either 203 or less. So A does not work. If you think about it, we can purchase more than 185, so that's not the minimum nor the maximum. So D is the correct answer. We can purchase 185, but that is not the smallest amount nor the most amount we can purchase. For number 17, if we're leaving a tip between 8% and 20%, remember 8% is the same as 0.08. You can use your calculator to recognize that. And 20% is the same as 0.2. So we want to recognize that our tip, aka y, has to be greater than 8% of the bill, which is x, but the tip, y, should be less than 20% of the bill. So in these options, we're given potential amounts of the bill and then potential amounts of the tips. So we have to recognize which one would work. Well, if we substitute 15 in for x in both of these, then we would get y is greater than $1.20 and y is less than $3. All of the other ones would not be true. For number 4, this is a linear pattern. The rate of change is 73, hence the 73 times n. And since this is the first term, we have to think about the 0 term, or the one that comes before it, and that would be 4,453, making this option A. For number 19, the cost to have any number of pizzas delivered to a home is described by the function C equals 8p plus 3. So if you think about this, 8 times p would mean $8 per pizza, and then adding a one-time delivery fee of $3, making the option C the answer. Number 20, which linear equation best describes the relationship? So since this is linear, we're looking for a constant rate of change. Notice change in y is 15. The change in x is 4. And we know rate of change, aka slope, is just change in y divided by change in x. So that is 3.75. And we actually don't need to go any further because the only answer or equation with a slope or rate of change of 3.75 is B. And number 21, the amount charged for a hamburger is based on the cost for a plain hamburger plus an additional charge for each topping. What does the number 0.06 represent? Well, we're multiplying that quantity by the number of toppings. So that number should have to do with something of the topping itself. T, we're told, represents the number of toppings, so that can't be it. H is the cost of the hamburger, that can't be it. And D would be the cost of a hamburger with one topping. Well, that would be when T equals 1. So H would equal 5.06, which has nothing to do with 0.06, making C the only possible option.